Okay, this is question number 1 from the third exam. It says solve for x. I'm going to write this in powers of 2, by the way. So that would be 2 to the 5x. Again, 2 to the 5th is 32. This would be 2 to the 6th times 2 to the x squared. So you get 2 to the 5x equals 2, 6 plus x squared. Well, the only way for this to be equal is if their exponents are the same. And I'm going to solve that. And what do you get? You get x squared minus 5x plus 6. I'm going to factor that now. And that would be what? I'd say 2 and 3. So x could be 2, or x could be 3. All right, that's done. Graph it. And what I do recommend is a table of values. I would say 0 might be a good place to start. And what would you get there? You just get 2. I would say 1. Well, 2 to the 0 would be 1. Right, that's not bad because, the exponent would be 0. And I tried minus 1. That would also give me 1. I would probably try 2. And what would you get over there? Well, you get 2 minus 4, which is minus 3, so it would be 1/8. And minus 2 would also give me 1/8. So I'm saying to myself is I probably could graph this now, just with a few points, right? So 0, 2. We're not looking for perfect pictures, by the way. 1, 1. And, minus 1, 1. It's symmetric. It's an even function. It's even. What else I get? 2, 1/8. Well, I got a really good idea what's happening with this. They're getting smaller. And again, I'm not saying this is perfect, but it's good enough. So I graphed it. Next thing is identify the asymptotes. I do see one. There's a horizontal asymptote, and that horizontal asymptote is y equals 0. Okay, identify intercepts. I see a y-intercept, and that's going to be 0, 2. Determine where the graph of the function is increasing. It is increasing, looking at my picture, from minus infinity up to 0. It's decreasing from 0 to infinity. I think that's about it. All right, use a property of logarithm to rewrite. Let's do that. I'm going to write this as x. I don't know what that is. So I would get 32 equals 8 to the x. 32 is 2 to the 5. 8 is 2 cubed, so it's going to be 2 to the 3x. So what are you going to get over here? 5 is equal to 3x, or x is equal to 5/3. All right, let's go to the next question. Next question, again, it's pretty much low-hanging fruit, most of it anyway. I think, what is or are the y-intercepts? Just set x to be 0. And what would you get? You get 0. That was easy. How about the x-intercepts? Well, looking at it, it would be 0, 0. I already got that one. And the other one's going to be 9, 0. Again, I'm just looking at the function to get that. What's the domain of f? I'm going to say all the real numbers, except where the bottom becomes 0, and that's at plus or minus 3. All right, what is the equation of the horizontal asymptote? Well, let me talk about this. And not that you have to put a whole bunch of work down, but we would love to see, work, and certainly articulate work. But I understand sometimes it's really tough to put work down. And what's our recommendation? Divide through the highest degree variable, which is x squared. You will get 1 minus 9 over x. On bottom, you get 1 minus 9 over x squared. And that would equal 1. That's a definite indicator of a horizontal asymptote, by the way. We also should go to minus infinity. So what's a horizontal asymptote? Y equals 1. All right, vertical asymptotes, a little more difficult, I realize that, but the candidates are going to be x equals 3 and minus 3. Now granted, we're pretty accepting of this, but let's write down what the work should look like. The limit as x goes to 3 from the right, f of x, the limit as x goes 3 left, f of x. We'll talk about this a little bit later. And look this over here, limit as x goes to 3, I'm sorry, minus 3 from the right of f of x, and the limit as x goes to minus 3 from the left f of x. All right, whoops, I'm sorry about that. I didn't mean to do that. That's not true. So how do we do that in class? We put a number line down, and I listed, the zeros in the problem, and I'll point out what those zeros. It's called sign analysis, by the way. One would be at 0. The other one would be at 9, and then you get plus or minus 3. And again, I hope you get any better with sign analysis. Like if you took a number like 10 and plugged it in, it'd be positive, 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 positive. So I know it's positive on this side. Now, if you took a number between 3 and 9, like, 6, and plugged it in, you get negative on top, positive on bottom, so it'd be negative. All right? I know it's tough, by the way. What do you do now between 0 and 3? Pick a number like 1. What would you get? You get negative on top, and you would get negative on bottom, which is positive. Now, between minus 3 and 0, I would pick minus 1. You would get negative times a negative on top, which is positive. On bottom, you would get a positive times a negative, which is a negative. So overall, it's negative. I would take a number below minus 3, like minus 10. On top, you get negative times a negative, positive. On the bottom, you get negative times negative, which is also positive. So positive overall. Now, someone says, why would you have done that? It helps me with the signs. So 3 from the right, it's negative. 3 from the left is positive. Minus 3 from the right is negative. And then minus 3 from the left is positive. Now, I do want to point out what's happening over here is we have divisions by zeros, so these things are going to be blowing up without bound. All right? So the range part, I understand is difficult. And most students don't do the work, by the way. They just take a guess at it, which is not a good idea, but I understand it. So I got an asymptote at 3. I got another asymptote at minus 3. I got a horizontal asymptote at 1. It's just a rough, dirty graph of it. And let's talk about this. From the right of 3, we get minus infinity, something like this over here. And then it goes up, it hits it here at 9, and then it goes towards that line. Okay, let's talk about the left of 3. It goes plus infinity. All right. Now, by the way, we have some points over here to worry about. We have a 0, 0 goes through over here, right? So I know it's got to do something like this now. All right. And then below the 0, it's negative, and it's going negative infinity. All right. Then to the left of minus 3, right? Looking at my limits and all the information that's given from over here, it's going to go plus infinity, and it's asymptotic with this, so something like this. So clearly looking at the graph of it, the range is all real numbers, or minus infinity to infinity, whatever you want to put down. I like to put this symbol down now. All right, so that's done. Let's do this one over here to solve for x. I'll write this down for you. This is going to be log base 2. And it's going to be 3x plus 1 over 5x minus 1 is equal to 3. I'll rewrite it as an exponential. So it's going to be 3x plus 1, 5x minus 1 equals 2 cubed. And this looks pretty easy to do now. It's a really simple rational equation. 3x plus 1, 5x minus 1. 2 cubed is 8. I'm going to multiply both sides by 5x minus 1. And what do you get? 3x plus 1 equals 40x minus 8. I can subtract 3x from both sides and add 8 to both sides. And now I'm going to divide through by 37. All right, I'm done with that. This one says find the domain. Well, the domain's pretty easy. It's 3x minus 2 is greater than 0, which means that 3x is greater than 2, which means that x is greater than 2/3. So, certainly log functions aren't that bad to do. And that's going to be 2/3. That's an asymptote now. X equals 2/3. Find the domain. I did that. The x-intercept. Well, the x-intercept's when the natural log. Whoops, I didn't mean to do that. When the natural log of 3x minus 2 equals 0, which means 3x minus 2 is equal to either 0, which means 3x minus 2 is 1, which means 3x is equal to 3, which means x is equal to 1. So I got a point over here. So the x-intercept is going to be 1, 0. This is the x-intercept. All right? Now what else do I have to do? Domain, x-intercepts, vertical asymptote. This is the vertical asymptote. The domain is over here. And it says, and graph it. Graphing's pretty simple. Something like this over here. And again, it doesn't have to be perfect. Something that looks roughly like a log problem. All right, given this, what's the equation of slant asymptote? That requires a long division. I'll put this down for you. X squared plus 7 is dividing into x cubed minus 8. So I'm going to say, x. And x times x squared is x cubed, right? And then x times 7 is 7x. So what do you get over here? Minus 7x minus 8. So I'm going to say this function could also be written as x minus 7x plus 8 over x squared plus 7. So the slant asymptote, SA, is y equals x. All right? What is it? What's the y-intercept? All you have to do is set x to 0. Right? When you set x to 0, what do you get? Well, you get 0, minus 8 on top, and 7, so minus 8/7. What's the x-intercept? Well, it's when the top becomes 0, and it becomes 0 at 2. We're just dealing with real numbers, by the way. What's a domain? Well, looking at it, there is no divisions by 0, so the domain is all real numbers. What's the range? Well, it requires graphing it. And this is where a lot of students don't bother with it, all right? So I notice an asymptote. It's a slant asymptote. It's y equals x. So I know there is a point over here, looks like that over there, and another point over here, like minus 8/7. Wait, it doesn't look right. Minus 8/7 about here. So I know it goes towards the asymptote. And it's got to go like something like this over here. By the way, this is rough. We're not saying it's terribly accurate. All right, what's the range of that? All real numbers. Just looking at the picture. All right, this one says rewrite this in terms of log, natural log 3 and natural log 5. So I got to look at 225. And the first thing I would do is I would divide probably by 5. So that's going to give me 45, right? And then I divide by 5 again. I get 9 and 3 and 3. Let's see if I did that right. 5 times 5 is 25. 3 times 3 is 9. And 9 times 25 is 225. So I could write this as the natural log of 5 squared times 3 squared. Well, I could continue to write this as the natural log of 5 squared plus the natural log of 3 squared. And I can write this as 2 natural log of 5 plus 2 natural log of 3. And we're done. This one says condense, one step at a time. These were all log base 5. This would be the cube root of x plus log base 5 y to the 4th power minus log base 5 z squared. Well, I'm going to condense it into one log now, log base 5. And this is going to be a quotient. And it's going to be the cube root of x times y to the 4th over z squared. That's done. This one's solved for x. There's many ways to do it. One thing I would do is, I don't know, maybe rewrite it without the negative exponent. I would multiply both sides by e to the x. And you would get 2x minus 6 equals e to the x. E to the 2x minus e to the x minus 6 equals 0. It looks factorable to me. E to the x, e to the x, and I would say 2 and 3. And what do you get there? Well, let's see. Give me minus 3 plus 2. Let's see if that works. E to the 2x, yep. Minus 3 plus 2 is minus 1. Yeah, looks pretty good. So there's two solutions here, right? E to the x equals minus 2, or e to the x equals 3. Well, in real numbers, not possible, but this is possible. When would that happen? When x is equal to the natural log of 3. All right, the last one is to expand this guy over here. And the way I would do that is log base 2. This is x cubed z5 over y7 to the 1/4 power. Well, I'm going to do one step at a time. You know what? Let me be consistent with my penmanship. Log 2, that would be x cubed z5 and y7. All right, let's keep expanding it. It's 1/4 times the expansion of that log now. So log 2 x cubed plus log 2 z5 minus log 2 y7. All right, let's keep going. One step at a time, 1/4. This would be 3 log 2x plus 5 log 2z minus 7 log 2y. Let's keep expanding it. And by the way, if you did this, this is fine. It's 100%. This is going to be 3/4 log 2x plus 5/4 log 2z minus 7/4 log 2y. And that's it. Thank you.